Good morning. Today I am going to discuss about the type of stresses and the stress strain diagram in this session. Now let's move on to this. What are the types of stress? Already we have discussed about stress. The stress is nothing but the internal resistance offered by the body to meet with the load, as well as the unit of the stress is Newton per meter squared. And what are the different types of stress? One is tensile stress. The stress is induced by the nature of load called tensile load, which is called stretching or pulling load. In this load, we are applying a load on this material. The stretch will be there, so that the elongation will be occurring. So due to the load, the stress produced in the material is called tensile stress. Generally, the tensile stress is considered to be positive stress. Next type of stress is called compressive stress. Here the nature of load is compressive in nature. So we have to apply a load on the material by means of applying compressive load. The elongation will not be there. Instead, the reduced in length will happen. Due to the reduced in length, lateral dimension will increase. So when applying this compressive load, what is the stress is produced on the material is called a compressive stress, as well as the compressive stress always being considered as a negative stress while mathematical applications. And we are going to discuss about the strain. Strain is the change in dimension to the original dimension. Generally, we have two types of strain called linear strain as well as lateral strain generally. Okay, and I already discussed about the strain. But what are the different types of stress as well as what are the different types of strain is the matter here. One is called a tensile strain, another one is called a compressive strain. So whenever the load is applied on the material gets strained. If the load is tensile, then the strain produced is called a tensile strain, as well as the nature of load is compressive load. The strain produced on the material is called a compressive strain. Next, we are going to discuss about the important topic called stress strain diagram. Here, a material is going to be tested on UTM, that is called a universal testing machine. Now we are going to apply the tensile load. So it can withstand up to how much load. We are going to test at what load the material will go to failure mode. We are going to discuss some of the quiz related to Hooke's law. First, we already discussed what is Hooke's law. It is the stress is directly proportional to strain within the elastic limit. That is the statement already discussed regarding Hooke's law. Now let's move on to some of the quizzes related to Hooke's law. First quiz is that the ratio of ultimate stress to the permissible stress. That is what? The options given are a factor of safety, safety ratio, safety measure, none of these. And the answer is factor of safety. Factor of safety is the ratio between the ultimate stress to the permissible stress. The second quiz is, which of the following is an application of Hooke's law? First one is, it is used in all branches of science and engineering. The second option is, it is the fundamental principle behind a manometer balance wheel. The third one, it is the foundation for molecular mechanics, acoustics. And the last one is all of the above. So Hooke's law is applicable to all the above. That means it is used in all branches of science and engineering, fundamental principle behind manometer balance wheel, and foundation for molecular mechanics, acoustics. So all are the applications of Hooke's law. The third quiz: which of the following is the disadvantage of Hooke's law? Options are: first option is it is not a universal principle. Beyond the elastic limit of the material, the law is not applicable. The third one is it is applicable only for solids. The third one is all of these. So Hooke's law is not a universal principle, and beyond the elastic limit it will not be applicable, and it is applicable only for solids. All are correct. So all of these is the answer. And fourth question is the strain of the material is proportional to the applied stress within the elastic limit of that material. The options are stress law, Hooke's law, Poisson's law, Bernoulli's law. So here I already told that Hooke's law is stress is directly proportional to strain within the elastic limit of the material. The same thing is given in terms of strain. The strain of the material is proportional to the applied stress within the elastic limit of the material. It is also Hooke's law. The answer is option B, Hooke's law. Fifth one, which of the following is an example for non-Hookean material, non-Hooke's law? Okay, so that is called as non-Hookean material. Copper, aluminum, rubber, steel are the options. So copper, aluminum, steel, so all are going to elastic range and plastic range, everything. But rubber, so you will not have any elastic material. That is, even it is an elastic material, that Hooke's law will not be applicable for the rubber. So the option is rubber is a non-Hookean material. Finally, last one thing is to be discussed. What is the change in length due to the axial load applied on the material? Actually, it is derived from the Hooke's law only. So here already given that the stress is directly proportional to strain, and we are introducing a elastic constant Young's modulus. So stress is defined by load by area, and strain is change in length by the original length, and Young's modulus as it is. From this we can have a del, factual delta L. So from that we can have an equation PL by AE, here EA, so no problem, PL by AE, where P is the applied load, L is the length, A is the cross sectional area, E is the Young's modulus. So the unit, when applying this mathematical expression, unit must be followed like if load is in terms of Newton and the length is in terms of meter, then the Young's modulus must be Newton per meter square and area must be meter square. If it is applied, load is applied in terms of kilonewton and length is millimeter, then you can use Young's modulus as kilonewton per millimeter square and area as millimeter square. So accordingly the unit must be followed while mathematical applications, so that we can get the correct answer, otherwise we will have a error. So that's all from this class. We will discuss later. Thank you.